Hello, I'm Kelly McConvey, a PhD student at the Faculty of Information at the University of Toronto. Thank you for being here, and I'm excited to present our work on algorithms and power in higher education. This work was completed with Dr. Shion Guha, the Faculty of Information and Department of Computer Science at the University of Toronto. For this work, we set out to explore what data and data-driven systems mean to higher education institutions, to the faculty, advisors, students, management, and even executive teams. We came up with two research questions to guide this work. Why are student data-driven and algorithmic decision-making used within higher education? And how are data and algorithms currently designed, used, and perceived by the various stakeholders of the higher education institution? Our research site for this work was Centennial College, a public college in Toronto, Ontario, Canada. Centennial is one of Ontario's 24 publicly assisted colleges that grant diplomas, bachelor's degrees, and certificates. Important to know is that the government has prioritized financial sustainability throughout a decades-long domestic tuition freeze in the province of Ontario. Public funding for higher education has gone from 54% to just 32% of total funding over the past decade. The province has also implemented performance-based funding model for 2023, and colleges have increased international enrollment sixfold from 2009 to 2019 to deal with this financial crunch. We conducted an ethnographic study at the college from May to August 2023. In this, we interviewed 33 participants at the college, including academic chairs, success advisors, data analysts, deans, directors, learning technology specialists, managers, professors, and students and VPs. Our fieldwork included semi-structured interviews, document review, and meeting observations. Once we had the data, we analyzed the data inductively using open coding and deductively to the ADMAPS dimensions of human discretion, bureaucratic processes, and algorithmic decision-making. The major contribution of our work is the ASP-I cycle, algorithms, student data, and power in higher education institutions. First, we looked at the political and policy factors that are impacting the college. Those include government policy, growth of knowledge capitalism, and the use of new public management techniques within the public sector in Ontario. We found that these three elements led to a prioritization of financial sustainability within the college. In order to meet those financial sustainability goals, colleges turned to a scarcity of resources. In order to allocate those resources more effectively and efficiently, the college began adopting data-driven practices, which led to a reliance on algorithms. This chain reaction from prioritization of financial sustainability through to the adoption of algorithmic decision-making was demonstrated in quotes from many of our participants from all across the stakeholder groups at the college. It included comments like resource scarcity and increasing complexity of student needs are the ongoing story at the college. Another participant told us that they're still responsible for turning a profit in terms of money to reinvest into further growth. So utilizing data to maximize revenue is a critical aspect of what we do. We see here that data is seen as a central critical element in meeting those financial sustainability goals. There was also the belief that the reason data is incredibly important is that you're able to allocate resources correctly. The college currently has 3 in-house developed algorithms, either in development or in use. These include a student-level enrollment prediction algorithm, a program-level enrollment prediction algorithm, and an early warning system, which is a risk assessment algorithm that predicts the likelihood of a student succeeding or not succeeding in their chosen program. To build these algorithms, the data science team at Centennial College turned to tools like DataRobot, relying heavily on automation in no-code environments to create models quickly and efficiently. We also found a kitchen sink modeling approach throughout the data science team, where vast quantities of data are collected broadly from all elements of the student's interaction with the college and thrown into the model. The data science team reiterated a number of times that in order to improve the model, you just have to try new features, that more data is the best way to go about model improvement. We also found a reliance on traditional model performance metrics, like accuracy. They felt that by automating a lot of processes, accuracy would go up, reinforcing this idea that throwing as much in increases your accuracy without needing a sort of sophisticated model development process. Finally, we found that opacity was a key element to the way the college approaches model development. Our participants were reluctant to share details about the model architecture, the underlying code, or even something as simple as the model's current accuracy score. This information was treated as protected or private information that only the data science team was privy to and wasn't shared widely with other teams. Much of our research focused on the early warning system at the college. The early warning system takes student data from across all of the college's systems, things like transcripts, enrollment history, registrar information, and attempts to predict the likelihood of students succeeding. Students are placed into buckets based on that likelihood, and students in the lowest bucket are introduced or connected with resources from the advising services area. These resources include interventions like a reach out email, one-on-one counseling with a success advisor, or attendance at a workshop. We found, though, very little evidence that the decisions being made by the model were being effectively connected to the interventions available. So a student might have a low likelihood of success based on something like the semester that they entered their program, and then be connected to an unrelated resource or unrelated intervention. This disconnect was a recurring comment throughout our ethnography, as participants were concerned that the model, while aimed to provide better resource allocation, was actually leading to greater work, as success advisors had to sort of pick apart the model's decision for each student to determine why it had made that recommendation and what intervention would then be most appropriate. Once we'd gained an understanding of why models are designed at the college and used, we began to look at how they're currently designed and what the impacts of those design decisions are. We also looked at the relationships between the different teams and stakeholders of the models and the further impact on students downstream. We found that a reliance on algorithms leads to an increased need for data at the college, increased surveillance of students, and increased weight on business division goals. First, we'll take a closer look at the increased need for data and the increased weight on business division goals. Because of the factors discussed earlier, automation, a throw everything in approach to modeling, reliance on traditional metrics like accuracy, and an opaque modeling system, really, the data science team isn't able to improve the model without an increased need for data. New data is effectively the college's only way to improve their model performance. We found that participants could be loosely organized into three groups: the academic division, like faculty and students, the business division, things like the data science team, finance, recruitment, and the students experience division, which is made up of our success advisors and other counseling staff. Budget allocation or resource allocation traditionally is a give and take between these three groups that all advocate for their own needs within the college. But as decisions increasingly require data as evidence in order to back up those decisions, those with access to data have an advantage in meeting their priorities. And currently, only the business division has access to this data. And as we've seen before, it's a fairly opaque process that requires quite a bit of negotiation with the team in order to get the data. So because of this, we found that there is a perception of an increased weight on the business division's goals, that they are able to better advocate for their goals and their priorities because they control access to the data. Returning now to our cycle, we found that the increased need for data, the increased weight on business division goals as a result of a reliance on algorithms, had a significant impact on students. These elements led to increased surveillance, an exacerbation of existing inequities, and automation of the faculty-student relationship. As the college requires more data for modeling, the only real way to obtain that data is to increase the way that students are surveilled. Participants mentioned wanting to move to using learning management system or learning analytic activity data within their models in the future, increasing the way that students are sort of monitored and watched within the classroom. We also found that the reliance on algorithms led to an exacerbation of existing inequities. As no group is specifically responsible or has ownership over the algorithms, very few checks or balances were going in for what bias exists. And concerns were raised about how students would access resources equitably when they were being algorithmically chosen for them. And finally, we found that the increased weight on business division goals meant that the faculty-student relationship, which we know from prior literature is a key component to student success, was going through a period of automation, where things like flagging students for extra help became the role of an algorithm and the data science team as opposed to faculty as it has traditionally been. Finally, we found that these factors combined to a sort of reorganization that led to an increase in institutional power that through the chain from financial sustainability to adoption of data-driven practices to reliance on algorithms and the impact of those algorithms on students, faculty, advisors, and the stakeholders across the college, that institutions had redistributed power from faculty and students to the institution itself. With increased institutional power and no change in the outside political factors like government policy, knowledge capitalism, and new public management, institutions still under prioritization of financial sustainability are then able to go and repeat the cycle in an endless loop, leading to greater scarcity of resources, to greater adoption of data-driven practices, to greater reliance on algorithms. Through this work, we propose a framework for understanding how outside factors contribute to the development of algorithms or reliance on algorithms within higher education that ultimately lead to an increase in institutional power. This framework is useful for understanding within public interest technologies and the public sector what the impact on different stakeholders can be and how power is redistributed through algorithms. By coding and analyzing our data with the ADMAPS framework proposed by Saxena et al., we were able to propose two major takeaways to this work. One, that balancing strength-based and deficit-based approaches will benefit all participants in an early alert system. Because deterministic scoring, like an early alert system, effectively boils students' potential down to a single value, and this has the potential to incentivize an anticipatory conformity at odds with the college's commitments to flexible and inclusive learning. As students try to effectively game the system, they will anticipate how their data will be used and change their behavior around it. But this goes directly against the college's commitment to things like universal design for learning or offering accommodations to students who require them, as students who interact with the college's different systems receive different access to interventions. We also find that holistic assessments, not deterministic scoring, lead to improved decisions. So models that aim to mitigate risk to an institution by attempting to quantify a student's success or risk lose important context about that student. By removing advisor and faculty discretion from this decision-making process or this flagging process, institutions risk increased potential for harm and a loss in trust in data-driven practices across all stakeholders at the college. Finally, we'd like to thank our collaborators and study participants at Centennial College for engaging in this work so openly and allowing us to conduct this ethnography. I'd like to remind everyone that opinions, findings, and conclusions expressed in this paper are those of the authors and do not necessarily reflect the views of our research site partner. Again, I am Kelly McConvey with Shion Guha of the Human-Centered Data Science Lab at the University of Toronto. Thank you so much, and I look forward to hearing your questions and comments.